The way data is partitioned in a Spark application can have a big impact on performance. We're going to take a deeper look at partitioning, what it is, and how we can affect it. If you recall, an RDD is a big collection of data items, records of some kind, and we're assuming that there are too many of them to fit on one computer, so we have to partition them. This diagram shows our list of names and ages, those key value pairs, being partitioned among a 3-node cluster. You'll see Alice and Tom are on that top node, Emma and John are on that bottom node, and Sarah and Bob and Ron and other Bob are on the middle node. Now, Spark automatically does this, but we're going to look at what automatically means and what some of the rules regarding partitioning are. RDDs actually expose an API that let you get at how they've been partitioned. There's a property called partitions, which returns an array of partition objects. You can, of course, count the size of that array and get the number of partitions that the RDD is distributed among. We also might want to understand the algorithm used to do the partitioning. Spark's going to be looking at each record in an RDD and doing something to it to figure out which worker node it should be stored on. The partitioner property tells us which partitioner the RDD is using. There's the hash partitioner, that's the most common strategy for key-based operations. There's a range partitioner, we'll use that when sorting by key is required. And partitioner can also be none, which simply means that the partitioning strategy isn't based on the characteristics of the data, but it is guaranteed to be random and uniform. There are a number of factors that can affect partitioning, the way partitioning actually happens and the way partitioning should happen. For example, the resources available to an application, the number of cores that its tasks can run on. There are external data sources, such as a local collection that you might parallelize, or a Cassandra table, or even potentially HDFS files. The size of those data sources can affect the way they get partitioned. Transformations used to derive a new RDD from an existing RDD. There are a number of rules that determine the number of partitions that, by default, will be used for the new RDD as a function of the partitioning of the source RDD. And we'll eventually dive into each one of those in more detail. When you think about an RDD in the abstract, we've encouraged you to think of it as a collection of records. And you might think of those individual records, like maybe rows from a Cassandra table, as the fundamental unit inside those RDDs. Well, as RDDs come to life on worker nodes, the fundamental unit of representation is the partition. The RDD is partitioned, broken up into pieces, stored on workers, and that partition, or that chunk of the RDD, is the thing that lives in that worker node. Now, the smallest unit of computation that Spark thinks about is the task. So we'll always find when we're looking at the status of a running application that the number of tasks is equal to the number of partitions. One task gets allocated to operate on one partition in one executor. You'll never have more tasks than you have partitions. Now, important to realize that's true on a per stage basis. You could potentially have multiple stages in an application that are operating on the same partition, but given a stage, we have one task per partition. Now, Spark needs to have a sensible default of a number of partitions to create for a new RDD. And that's represented in the default parallelism property of the Spark context object. That is defined by default as the number of cores available to the application. Now, you can override that if you'd like, but that's a good place to start. We often find when we're measuring performance and actually optimizing that we want our number of partitions to be greater than the default parallelism, which is why controlling partitioning in Spark is so important. In fact, it's probably the most important optimization step that we're going to learn. We're going to learn that there are actually special transformations for repartitioning data sets with the partitioning properties that we'd like to see given the structure of our application. We'll find hidden in the API, on most transformations, we have the ability to specify how many partitions we'd like the resulting RDD to have. And we'll see other application settings that affect the way partitioning works.